In this video, I'll show you how to find the sum of infinitely many terms of geometric progression. The question reads, find the sum of infinitely many terms of a geometric progression shown below, 9, 3, 1 and a third, and so on. To do this, we'll need to use the following formula, where S represents the sum, A represents the first number, and R represents the common ratio. The common ratio is the number in which each of these terms are multiplied by to get to the next. So what do we multiply 9 by to get to 3? What do we multiply 3 by to get to 1, and so on? Well, I know that 9 divided by 3 is 3, and 3 divided by 3 is 3. So instead of using divided by 3, I can say R is equal to 1 over 3. And remember, R needs to be less than 1, and in our case it is. A, on the other hand, is equal to 9, so I'll substitute these values. S is equal to 9 over 1 minus a third. Let's use our calculator for this. 9 divided by 1 minus 1 over 3. This gives us 27 over 2, or as a mixed fraction, 13 and a half. Let's move on to question 2. In question 2, we're asked to find the sum of infinitely many terms of the geometric progression shown below. Let's start off by defining our common ratio, R. How do we go from 10 to 2? I know I divide by 5, so our answer has to be 1 over 5. A represents 10. I'm going to substitute these values into the formula. S is equal to 10 over 1 minus a fifth. Using our calculator again, 10 divided by 1 minus 1 over 5 gives me 25 over 2. Or, as a mixed fraction, 12 and a half. And so there you have it. 2 examples on how to find the sum of infinitely many terms of a geometric progression.